And here's how the rig looks like. So the graphics card is an old NVIDIA 6500 GT from 2005. It's on the bottom slot, only to display the monitor signal, as you need the lightest possible graphics card to stress the whole system. So this is one of the oldest ones that are available for the PCI Express slot. So the driver for this graphics card is very, very small. So that's why I really like to use it. The reset and power buttons are hidden at the bottom of the bottom side of the motherboard, so they are quite hard to reach now due to the graphics card. And there's also the other CMOS clear button next to the power button, so you have to be very careful that you don't accidentally press it while the motherboard is running. I set up this quite strong fan to cool the Northbridge heatsink as well as the CPU VRM heatsink, as they do get warm if there's no airflow. You should be using the SATA 3 ports for the most part, but right now I'm using the Intel SATA 2 ones because I'm using a recycled OS just for this test. So if I try to boot this, it will just give 7B blue screen. So there's that. So just let's start the system right now. You have the debug LED on the bottom right part of the motherboard. Alright, so the way to update the BIOS on all of the EVGA X58 motherboards is quite tricky, because there's just one BIOS chip and there's no built-in BIOS update functionality inside the BIOS. So you actually have to boot a device like a DVD or a USB, and then you just update the BIOS in a DOS environment. So it's quite tricky and very annoying and old way to update a BIOS. But anyway, so I have a USB stick set up. So I have a USB stick set up, and I just have to select it as first boot device. I'm not fully sure if it works better as removable or hard disk, and then I just have the Kingston Data Traveler 3 as the only boot device. Sometimes it doesn't boot correctly, so it kind of goes into some weird boot attempt mode, and it doesn't boot it correctly. It will ask that, do you want to boot the device or no? So I just have downloaded the BIOS from evga.com. I have renamed it to bios.iso, and then I just have to use the bootable stick to update it. Cannot find. So yeah, so it's much easier way to flash the BIOS by using a CD. So here we can see E770-77.bin. So based on the information you can find online from old forums like Extreme Systems, the versions 74 and 77 should be the best ones for the EVGA X58 motherboards when overclocking the Gulf Town CPUs. The latest one available from the EVGA website right now is are the last ones from 2011. Those are the versions like 84 or 85 or 86, something like this. And apparently they should be worse than these older versions. So the 77 and 74, they are from like late 2010. So I will try that now once it updates. So there's definitely some issues with the USB flashing complete. So hit F10. So now it should be done. Okay, so now once that the BIOS has been updated, we can now take a look at the actual BIOS. So this is just some inside information from old forums that these two specific versions should be the best for all the X58 classified motherboard versions. So that's why I wanted to change the BIOS or revert back to older version. So In the main standard CMOS features, we don't find anything. In the advanced section, you can just decide what device you want to boot. So of course we just have our SSD and nothing else connected on the motherboard. In integrated peripherals, you can change the SATA mode between IDE, AHCI and RAID. We will keep that IDE as we are using Windows XP. The legacy mode support, I'm not fully sure that which operating system versions require this, but maybe you have to enable it if you want to use the SATA 3 ports. I'm not fully sure, but I would guess yes, because for some reason I got blue screens when I tried to boot my recycled Windows XP from the SATA 3 ports. So I think you have to enable this. In onboard device, we can disable the LANs, Realtek LAN, the FireWire and audio, as we don't want any extra stress on our operating system when we are using Windows XP for 2D like SuperPi, W Prime and so on. No USB sticks right now, but yeah, so just use CD to update the BIOS. It's much easier than USB. I did so many failed attempts when I tried to update from a USB stick. The overclocking is in the frequency/voltage control. The way you overclock the EVGA motherboard is very easy. So the dummy OC, maybe this is some easy overclock for dummies, as the name would suggest. Extreme cooling is just two-phase overclocking for LN2. So I think mode 1 is for chilled water, single stage, and mode 2 is cascade LN2, and maybe mode 3 is for full pot LN2. I've not tried them, but yeah, so we can just now start. So the thing about multiplier control inside the OS is that it only works on X CPUs when you have enough multiplier so that the turbo performance is enabled. So I'm not fully sure what is the limit. I think it's 20 something, but at least that was on the E760. So if multiplier was too low, I could not change the multiplier inside the OS. So it shouldn't be an issue for LN2 when we have enough multiplier anyways, but when we are just using like 24 on water, it's very likely that we cannot change the multiplier due to that. So let's check. Actually, we have to set this to 210 when we want to get the best possible memory. So this is the 7.2 GHz 980X that I have in the socket right now. It does 4.8 W prime with 1.4x something volts. But now I will just test the memories quickly. So I'm going to run 210 on the base clock with 23 multiplier, so it gives 4.8 something and 4.6 on the Encore. This is very high Encore for any X58 CPU on air or water cooling. But this CPU just can run it so high, which is very nice. You want to enable OC recovery so that it will load default settings if something goes wrong, so you don't have to CMOS clear that often. But turbo performance has to be enabled somehow for the multiplier control to function inside the OS. At least it did work with the 760, but I still have to check that is there some issue with the with this motherboard particularly. So we will see. So those are the settings. So in voltage, the good thing about the EVGA X50 classified board is that when you enable load line calibration, it's very spot on. So now I will set 1.4 on the V-core, and I checked it with a multimeter. So when you have any voltage set with load line calibration enabled, so without V-droop, that means load line calibration is enabled, the voltage under load is very spot on. So when I ran W prime at 1.4 set volts, the voltage under load during W prime was 1.406. So it's very spot on. So it's a touch over the set value when you have load line calibration enabled. The VTT is a bit complicated on the X58 classified boards, so you control it as an offset, so you have to set extra on top of the default value. So now I'm setting plus 300, but there's one thing I need to tell. So when we go to PC health status, we can read that CPU vCore is 1.15 as default, and CPU VTT it reads as 1.23. So this would mean that with plus 300 I would get 1.53. It's quite high, but when I checked with a multimeter, the value that the BIOS reads is actually a bit too high. So the BIOS is reading 50 millivolts too high value. So if the BIOS is reading 1.5, multimeter will give you 1.45. So you can only know this by measuring it yourself with a multimeter. So it happened the same on the classified 3 as well as the original classified. So just remember that the value is 50 millivolts too high in the BIOS. The temperatures over here are CPU temperature, Northbridge temperature, so this is the temperature of the X58 Northbridge, and VREG temperature, which means the voltage regulators, aka MOSFETs. So this is the VRM temperature of the CPU. So they do get warm if there's no airflow at the socket area and the heat sinks. So let's go back to the overclocking. So voltage, so plus 300, I will get around 1.5. The risky part about memory overclocking with X58 CPUs and later was that too high memory voltage could actually damage the CPU itself. You have to keep 0.5 volt delta between the VTT and the actual memory voltage. So if you want to use 2 volts on the memory, you have to use at least 1.5 on the VTT or a bit higher to lower the risk of any damage on the CPU. So this was the reason why the 1.65 voltage limit was introduced to memory kits. Memory itself can handle much higher voltage than 1.65, but it's because of this potential risk on the CPU why it was introduced. Good thing, apparently a good thing about the EVGA X58 classified board is the insane range on the CPU PLL vCore. So on the CPU PLL voltage, you can go much lower on the CPU PLL than on any other competitor motherboard for the X58 platform. So the like the Rampage 3 Black Edition, Rampage 3 Extreme, and X58 AOC from Gigabyte, they cannot go lower than 1.4 volts roughly. So this can go even under 1 volt, like 0.6. It's amazing, like really. And even on the high side, you have much more range. So the max value for Rampage 3 Extreme and Black Edition is 2.1 roughly. It's not enough for this CPU. This CPU needs at least 2.3 for full pot. And this can go like 2.7. So this has definitely enough range for the CPU PLL, so it's very, very nice. Now we will use a bit under stock value, so stock is 1.8, I will set 1.725. This is the IOH input-output hub, so this is the Northbridge PLL, I will set it at stock value. QPI PLL it can affect overclocking on LN2, so I will set it a bit over the stock value of 1.1, so 1.2. DIMM voltage is the memory voltage. As we are going to run quite high, I will set it at 1.94. Auto on the VREF. This is the actual Northbridge voltage, I will set it at 1.2. This is near stock. Then you can change the PWM switching frequencies for the VTT as well as for the vCore. So at least in theory, higher the better. So if you set it to the highest value possible, it should have a faster transient response, but it will also lower the efficiency. So if you use the highest settings here, it will just mean that the VRM get a bit hotter than at the lowest value. So just keep in mind the possible temperatures, so have adequate cooling at the heat sinks. CPU impedance and QP, I think these are just for LN2, so we will just leave them like this. So double check everything. Then for memory, we will run memory SPD standard, control enabled, memory frequency we will set. This is quite tricky, so this is the default multiplier, and then it's just calculated with the actual base clock. So now we have 1333 times 200, so it will give us 2.1 gigahertz on the memory. And then we will just select 6, 7, 5, and 21, and common rate 1. The common bug about X58 for pretty much all of the boards was for me that I had better performance with 686 timings compared to 676 or 675, so I still need to double check this. TRFC we want to run quite tight, so 68. TREF, highest value is the best on the refresh interval. So this is the only value that differs from all other values for memory. So set it to max value of 1023. TRRD should be good at 4. For active window I will set at 16. TRTP I will set it at 4 as well. 4 or 5 should be good. Write recovery time of 10 is usually very good. And these are pretty much it. I will not change these myself. So the memory is done, voltage is done. So now I will just, in CPU features, I will disable the execute disable bit. The execute disable bit is some protection thing, but we are not connected to internet or anything, so I will just disable it, and I will disable hyperthreading. Never disable the physical cores on any Golftown CPU. The common bug, which you can still find on Extreme System, is that if you set physical cores to 1 or 2 on a Golftown CPU, it will kill the CPU permanently. So be very careful. Here you could enable the slow mode on QPI, but I will leave them enabled for now. And now we will just save a profile. So 4.8 CPU, 2.1 MEMS, 4.6 on Encore. So now we can just F10 and go to the OS. So now I'm in the OS. We can read on CPU-Z that the vCore is spot on 1.4 as we set, 980X, no hyperthreading, and memory is triple channel, 4.6 on the Encore, 2100 memory is roughly, 675, 21, 68 common rate 1, 6 gigs, 2 per stick. And in mainboard tab we can now read EVGA X58 3X SLI classified 3, so E770, and the BIOS is the version 77, so I reverted it back from the latest retail to October 25th, 2010, so this should be a BIOS by Shamino. So, but the thing about the multiplier control, as I said in OS, it's something about the turbo mode. So the multiplier has to be high enough to be able to change the multiplier in the OS. So now it says 23 like we have set, but if I try to lower it by 1, I don't think it works. So nothing happens. So I will double check this when I run the CPU at stock base clock, so I can run higher multiplier. Will it work? But it should be about the it should be about the turbo mode. On LN2 it will not matter because we will have a high enough multiplier anyways. But yeah, so just for you to know, base clock you can change. You can change with the software as well. Then you have set FSP, but there are some issues with it. So this board uses. Why is it not working? Try to set 212. And now it's set, so it's quite buggy the way it works. But there are some issues with the set FSP, so you can find the clock generator between the first and second PCI Express slot on the motherboard, and the version is the one that ends with 139A KLF. So this did work on the E760, but when I tried it on this, it gave, it just hangs the system when I try to set it, and it doesn't go in lower increments than 1 megahertz. So now if I try to set it from 210 from 210 to 211, yeah, now it worked. So this is probably the reason why to use old BIOS. So when I tried with the retail BIOS, it always hang the system. But with the versions like 74 or 77, this does actually work. So now I will just set it back. So yeah, definitely use the BIOS 77. So now it works and no hangs. So this is for sure easier way to change the base clock. So use ZFSP or EVBot to change the base clock if the ELEAD doesn't work. And now I will just confirm the multiplier control with lower base clock. But now, so when I overclock these old CPUs like 980X, 920, 950 and so on, I just use W prime to check the multi-threaded stability, and for memory and so on I use SuperPi. So it's very straightforward. So you just run lowest 16K, which I already got, 32M. I use OCX SPI tweaker always. I don't do this manually. Sometimes I do, but quite rarely. So it's very straightforward. Let the thing finish, and then we will just wait for the available physical memory to ramp up to the max value where it will stop, and then we will run 32M. I will double check that is the how is the performance with 675 compared to 676 and 686, and see which is the best, because it has been the same story so far always that 686 gives me the best performance. But so far with the classified boards I cannot run as high memory frequency as on Rampage 3 or X58A OC. So that means that it sets the things much tighter already at post compared to Rampage 3 or X58A OC. So in some way it's a good thing, I think. So now we will just check. So yeah, this is already worse. This is a bit slower than what I got with E760 at same timing, so 675. So the first loop is 20.547. With the E760 I got, the first loop was 20.484, also 675. So now I will just change the memory timing so to 686 or 685 and see if it's faster. Yeah, it's already faster. So now I have 686.21. Command Array 1, all the subtimings are the same. So the initial value was already like 25 or 30 milliseconds faster already, and loop 1 is over 100 milliseconds faster. So I'm not fully sure why this acts like this on all X58 boards. Does it affect the like the round trip latencies somehow when you have the 675? It was actually the same with 685. So maybe it doesn't like the TRP of 5. But yeah, so but also I don't get why 686 is always faster for me than 676. But yeah, so you have to test this yourself. You can of course use newer operating system and Cinebench etc. for testing, but the most popular benchmarks back in the day of X58 and 775 were pretty much the stuff you run in Windows XP, like W Prime, PyFast, SuperPy 1M, 32M when it comes to 2D. So those are usually the tests I use as I just run Windows XP with these old platforms. W Prime is pretty much the same as Cinebench in many ways, so you can use that. And now we will just let this to finish. But yeah, so now we will just have to get on testing on LN2. Performance wise, the EVGA looks quite good. Sadly, I don't have good direct comparisons, like how is the efficiency with like on Rampage 3 Black Edition or X58 AOC. So is this faster than those at same settings to explain the lower maximum memory frequency? There's no huge difference, but there's some. But yeah. And here is the finished run. So the time was 7 minutes 20.609 seconds at 4.817, 4.6 Ancore, 2100 MEMS 686. And when looking at other like submissions at with same or similar result, we can see that the other guys have run the CPU speed at like 5.1. So I'm like 300 megahertz behind in frequency, but I have the same performance. So that shows that how good performance this rig over here has. So definitely good efficiency on the EVGA board and on the MEMS. So it's quite hard to compare the two boards that is the 760 better with 675 or similar, but they seem quite similar in the end. So now I will test W Prime and the multiplier control. So now I've set CPU to around 4.8, 1.42 volts, 4.6 almost on the Ancore, etc. So let's try W Prime. I use CoreTemp to measure the temperatures, so its temperatures were from lower 60s to around 70. So it did pass. Quite nice result of 3.359. Let's try again. So let's try 1024M. Temperature is quite high. When I ran the 6-core Xeon 5675, it was like almost 10 degrees cooler on average, like 5 or like 8, like 7 to 10 degrees cooler. So if this doesn't pass, it's because of the temperatures. But anyways, this CPU has been tested for around 4.8 with a bit over 1.4 volts. You can check the voltage from the tabs. So the VCO is the first one, and it will measure 1.435. So there's no much overshoot. The set value was 1.425. So it's like 5 to 10 millivolts of overshoot, but it's very, very accurate in the end overall. And let's see if it will pass. 98. Yeah, and it did pass. So that's very nice result for the EVGA X58 classified. So now we can try to lower the voltage a little bit and see what's the lowest value. What's the lowest peak core value we can pass at around like 4.8 roughly. It's not, the value in the BIOS said 4.817, but it seems to vary a bit. I don't know why. But it's close enough anyways. So at least W'32 passed at 1.4 set volts. Temperatures from 58 to mid 60s. So now let's try 1024 amp, but I'm pretty sure it will not pass, as it lasts quite long. But yeah, let's try anyways. Around mid 60s on the temperatures. Yeah, this will not pass. The cores are too different from each other, so it will just lock at 100%. So yeah, there were some errors, but yeah, the measured value and load was 1.406, so it's very on the edge. So 1.41, 1.415 should pass, so it's a very nice result. Alright, I think the limit multiplier for the operating system multiplier control is 26, because if I have it at 25 in CPU feature, the turbo mode function is not locked enabled by default, but if it's at 26 it gets locked permanently like this. So I will try this now. So 26, and does it work in the OS? And the way to conclude this now in the OS, as we can see, here's CPU Z. It's 3.6 GHz, as the base clock is only at 140, 26 multiplier. So if I'm right, this is the lowest multiplier you need in order for the multiplier control to function. We can see that the turbo mode is automatically now ticked. So if we try to set 27, and boom, it works. So yeah, I was right. So you need a multiplier of 26 or higher in order for the multiplier control to work in the OS. So this differs a little bit from the Gigabyte X58 AOC. With that board, you can control the multiplier of any X58 CPU for the most part. So even those locked Bloomfields and so on. But for the EVGA, you need an X CPU that has high enough multiplier control and a multiplier value of 26 or higher. So that's how it works. Alright, so that's pretty much how the EVGA X58 classified 3 performs. This and the E760, so the original classifier, they are pretty much the same. So it's nearly impossible to draw a conclusion based on water tests that which one is better. But yeah, so so far you do need the very old BIOS on the classified 3 as well. So it was probably from Shamino. So with that, you have the proper base clock control with ZFSP. So it's from October 2010, version 77. So I will link that in the description down below, because those are very hard things to find nowadays. Same goes for Elite. So I will put those. And I tried to figure out what is the possible thing about efficiency when you run 675 versus 676 and 686, but I cannot figure it out. So I tried all the round-trip latency things, the back-to-back cache delay, but no. But so far, when it comes to Elpida Hypers, the best performance comes with 686 timings. So I have to stick with those. It happens on all boards. So this motherboard should be ready for LN2. There's definitely enough range on CPU PLL. So now it's only about the thing about the IMC code block, can it go to a full pot with all 3 memory channels, which are needed for best performance in SuperPI and so on. So we will test that. So I will go on LN2 within 1 week if nothing comes in way. So yeah, so if you like to see this old motherboard, this really looks promising performance-wise. I think it can be the ultimate winner when it comes to X58 overclocking on Gulf Town. For Bloomfield, the Rampage 3 should be better because it can reach a bit higher base clock in the end. But yeah, so this is how the X58 classified 3 or 760, as they are pretty much the same, so how they perform. So like this video if you liked it, and subscribe to my channel, and I'll see you all next time.